so when we officially start, I think I'm just going to ask people to introduce themselves. David, if you'll start. Steve, second. Kajung, you third here.
Yeah.
All right, I have gotten the streaming service going and the webinar going. We have 3 attendees. Nate, the con is yours. There'll be Q&A. Questions will pop up down at the bottom, Courtney, or they might show up in the chat.
Okay.
And I'll go see if I can find Will McCarthy and browbeat him into showing up.
Okay. Well, I think we're officially online right now and streaming. This is a panel that was started last year, actually, discussing the year in science. And there's 4 of us right now, and we're looking for number 5. But I'm going to ask our panelists to introduce themselves. David, would you start?
Sure. My name is David Lee Summers, and by day I write science fiction, steampunk, horror, and by night I operate telescopes at Kitt Peak National Observatory, and we have actually been closed for about the last 7 months because of the COVID pandemic, and but we're getting ready to restart operations on the sky. But it's been a lot of our science has still been going on, people working with data behind the scenes, and a lot of people working from computers at home and learning how to do this whole business from home, which I think has kind of been an interesting experience.
I'll go next. I'm Steve Wall. Obviously I'm here for comic relief because this is an esteemed panel, and I am an imposter, I think. So my background is that I've been doing software development since 1970, and I am a voracious reader of both of current events, science, and science fiction.
Okay, thank you, Steve. Will, we're introducing ourselves. Can you hear us now?
Yes, I can hear you. Can you hear me?
Yes, we can. Why don't you introduce yourself?
Okay, well, I'm Will. I am a former startup founder, and I hold 31 patents. But I think my primary qualification to sit on this panel is that I'm a science fiction writer.
Okay.
And I am Kachun Yu. I am an astronomer at the Denver Museum of Nature and Science, although I guess from my background, I'm socially distanced en route to Jupiter right now too. But I've done panels like this for multiple years at MileHiCon, so I'm happy to be back.
Thank you. And my name's Courtney Willis. I'm an old man, so that means I'm retired from the physics department up here at University of Northern Colorado. It looks like we have a broad range of backgrounds and stuff here. The one area that I think we're probably going to be a little thin on is the life sciences, because I know everyone else here, and it seems like most of us are more in the physical sciences, but I've got a few things that I've looked up and stuff. If you have anything, let's make sure we try and get it out, because I think we're going to be slightly prejudiced this time here. So, let's start off. What do you think is one of the most interesting new developments that you've heard of in the last year or so? By the way, since this is supposed to be the year in science, but it's sometimes kind of hard to tell exactly when something is, so we may back into 2019 a little bit further, but pretty close. I think we should be in pretty good shape. Kachong?
Well, I think probably one of the most exciting discoveries happened just last month, and that's the announcement of the possible discovery of phosphine in the atmosphere of Venus. And that is exciting because, at least on Earth, phosphine is a byproduct of life, as well as meth labs. So we don't think there are meth labs on Venus, but it comes from decomposing fish and bacteria. You do find it on Jupiter, but that's only because Jupiter has huge amounts of hydrogen, which can lead to a chemical process that creates phosphine. And so that has gotten a lot of people excited. And even Carl Sagan projected in a paper in 1968 that about the possibilities of life in Venus's clouds. But whether this is an actual proof, I think even the scientists that are spearheading that research are not quite ready to say, just because, like Sagan says, extraordinary discoveries need extraordinary proof, and we're right at the beginning of learning more about this, and there has to be a lot of things that have to be overruled before we can say that this is definitively due to life.
Isn't there some speculation that it might be contamination from one of the Russian probes?
I think, they're doing measurements of broad regions in the atmosphere. So you would have, and they're using radio telescopes from the Earth to do it. So these are not in situ observations from spacecraft. So when you're looking at Venus, even through a radio telescope, you're seeing a big fraction of the atmosphere. So I don't think small probes. I mean, I haven't actually heard the arguments. I don't know what the exact arguments are, but it seems unlikely for a small probe to release enough to show up as a signal.
What I meant is the Russians did not sterilize their spacecraft, and the thought is that something might have survived in the Venusian atmosphere, some bacteria or something. Okay. It may be a kook theory. I heard it yesterday. If you're not familiar with it, then that says something.
Yeah. I don't think I can say much more about that.
It brings to mind that maybe we're looking for life outside of Earth, and we may encounter it. What if it's hard to get anywhere where life is not? That is pesky life. That it just seems to be everywhere we look.
And it also says something about the history of the solar system, because we know there's a lot of evidence that Earth, Mars, and Venus actually had very similar conditions very early on in the solar system. And Earth is the only one that remained habitable since over the last 4 billion years. And Mars dried out, got very cold. Venus went the other direction. It also lost all, or if not most of its water, and dried out, but also got very hot. But what's actually really interesting is that people assume that Venus dried out long ago, but there actually has been some more recent scientific work in the last couple of years which suggests that Venus actually didn't go into its runaway greenhouse phase until perhaps 1 billion years ago. And so Venus might actually have been habitable for the first couple, to maybe even 3 billion years of its history, in which case that's, we know that Earth became infested with life pretty early on. And so it's kind of crazy to imagine having two roughly, planets roughly the same size, both with life on it in the solar system, and then one, the life eventually petered out because it got too hot.
Well, and there's pretty good evidence that the planets are capable of exchanging material, and that there are life forms that are capable of surviving that journey. So, I mean, the Panspermia Theory has a lot to recommend it. There's a paper by Robert Zubrin that strongly indicates that bacterial spores can even survive an interstellar journey. Not a terribly long one, but they can, reach neighboring stars, and given enough time, where they could get everywhere.
And certainly one of the big pushes in the astronomical community right now is trying to find evidence of life outside the Earth. It's the one thing we have not actually demonstrated yet, but we keep seeing these markers, the carbon molecules that are necessary. We're in a big search for planets in habitable zones, which basically just means planets that are far enough from the sun that liquid water doesn't just evaporate off the surface, but close enough that it doesn't freeze. And I think we're seeing a lot of these, markers like the phosphine, seeing carbon out there. I think the sense is that we're just a matter of time before we find life somewhere either within the solar system or outside the solar system. And there really is just a tremendous push to try to find this.
And of course, the current rover that's just been launched to Mars, Perseverance, its main goal is to look for evidence of biology, and it will be collecting samples that it will package up, and they'll be collected for a later sample return mission to Earth. And so, I think Steve Lee later on in this conference will probably have more to say about that. But it's definitely exciting times as far as astrobiology and the search for life elsewhere in our solar system and elsewhere in our universe, as Dave says.
I have a question for you, Kachun. This might be slightly off topic because it's not a discovery that happened this year, but it's something I'm wondering why it's not happening. Back before we had close-up images of Pluto, there was an effort using long-term observations by the Hubble Space Telescope to reconstruct what the surface of Pluto must look like. And it was awful. The result was very low resolution and didn't really match up with what we actually discovered there. But now we have the ability to take those Hubble observations and correlate them with the actual surface of Pluto, which we know what it looks like. Has anyone thought about training an AI to take this very, very faint, constantly changing light signal from a rotating planet and turn that into images that actually do look like a planet?
Yeah, that's a really perceptive idea, and that's something that people have worked on. So, even right now we have the ability to sort of sample the atmospheres of distant planets that are in orbit around other stars, especially if we, currently most of the planets that have been discovered are via a transit method, where you're looking at a star that passes in front of, or a planet that passes in front of its star. And if you measure the starlight without the planet, and then you also measure it with the planet in front of it, and you subtract the two, if you have enough signal to noise, you can actually get very low resolution spectra of the component molecules in the atmosphere. And it's expected, as we are able to put better and better telescopes up. I'm not even sure James Webb will be able to do this, but at some point, you can imagine building telescopes that can image a planet, an extra solar planet, with, let's say, 10 pixels. And of course, how much resolution you get depends on its distance as well as its size. All those are variables that will play a role. But people are trying to figure out, if you have a planet that's rotating, and it has clouds, it has some fraction of oceans versus land, what can you work backwards? What can you get out as far as creating a map or a rough atlas of these extrasolar planets? So people were writing papers about what sort of techniques will be needed to extract that bit of information, even if you only have a couple pixels on that planet.
Yeah, and I can confirm, yeah, James Webb is actually, one of the things in its mission is to actually start taking some of these spectra of planet atmospheres to start seeing what they're composed of. And so I don't know what kind of resolution it'll have on imaging. Like we do have earlier this year, we had our first image of essentially a pole-on solar system going around a K-type star, which is very close to the sun. And that was done with the VLT in Chile. And you know, that's pretty exciting because now we're actually starting to get to the point where we're imaging planets around other stars directly. And that can lead us to both some ability to do some of the spectroscopy and find out what's actually there.
Yeah, I mean, even with the best, 10 meter or even 100 meter telescopes, or close to 100 meter, which is the next telescope design that's currently in the pipeline. I think it's maybe 50 or 60 meters. I'd have to look it up. The closest exoplanets will still be points of light, so you can't really get any information. But you will be able to do spectroscopy, from the atmosphere or from the surface, and there are ideas about star shades that will allow you to block the central light from the bright central star that tends to overwhelm light from the planet. And so those are ideas for telescopes that are orbiting telescopes that are decades down the line. And then in order to create actual images where you have multiple pixels on a planet, now you'd have to talk about large interferometric arrays in the visible part of the spectrum as opposed to the radial, because you need really long baselines in order to get the resolution necessary to do the imaging. So we're talking about, perhaps hundreds of meters or kilometers for the baselines, and you'd have to have orbiting constellations of telescopes that would allow you to do that. So that's many decades away, probably.
Steve, do you have anything that you think has been interesting scientifically in the recent past here?
Well, the imaging of the black hole I thought was a marvelous accomplishment, and the amount of computation that went into doing that, I mean, was astronomical. For at the end they ended up with a donut, but
Truly astronomical.
yes, I thought that was a great accomplishment that was done. And I wanted to ask, I just was looking at my bookshelf here and I saw one of Will's books, Hacking Matter. Is anything interesting happened with material science this last year?
Oh, there's always stuff happening in materials science. One of the things that's kind of exciting now, I mean, we've all heard of graphene, the two-dimensional carbon chicken wire, but people are exploring other kinds of two-dimensional molecules that use different combinations. Some of them are all one molecule and some of them are combinations of molecules, but all of them have
froze up on us. Well,
sorry, what?
You kind of froze up on us for a moment there.
Okay. There's a lot of exploration happening right now in other two-dimensional molecules that involve different combinations of atoms. And they have properties that can't be found elsewhere in nature. And so I guess they can't be found at all in nature because these are not naturally occurring substances. But look for developments there, yeah.
I've heard that 2 sheets of graphene put together and twisted can become superconductors. Do you know anything about that?
Yeah, it's, the trick with superconductors obviously is you want to get the temperature up as high as you can.
Right.
But the other trick is you want to get something that you can actually use as a basis for technological devices.
Right.
So I think the superconductivity that you're describing, it's a neat trick. Making practical devices out of it, I think, would be difficult. Another thing that happened really quite recently, though, just this past month, was the first ever room temperature superconductor. That's obviously a very big deal, except that the pressure required to make the superconductor is about on par with what you'd find at the center of Jupiter. So again, not very practical. But as we chip away at the edges, if we find, you know, bits and pieces of the outer envelope of what allows superconductivity to happen, we want to eventually shrink that down to the magic material that we're looking for. But I think, you know, I think you're onto something in the sense that these two-dimensional molecules, either by themselves or in chiral stacks, have tremendous potential to unlock electrical and magnetic properties that aren't otherwise possible.
David, what do you have?
Well, I think the one that really got me, and this was as much because a lot of my background was in things like supernova research and basically stars at the end of their lives, was there was this discovery from the TESS mission, which is the mission that's out looking at the nearest 500,000 stars around the Earth to basically determine which ones have planets around them. And there was this discovery of a planet orbiting a white dwarf. And of course, a white dwarf is basically what happens to a star like the sun at the end of its life. The core is collapsed and it's blown off the outer shell of the planet, or of the star rather, but there is this Jupiter-sized planet in close orbit around this white dwarf. And it's an indication that planets may very well survive this last phase of stars. And we have discovered planets around basically dead stars before. We've actually discovered planets around pulsars before, which are actually the remnants of stars that have actually blown themselves up. Now, the theory there is that these are probably planets that reformed from the material that blew off of the star. But this is probably a young enough white dwarf that this was probably a planet in orbit around that star before it became a white dwarf. And just interesting to see that kind of thing actually turn up in the data.
Yeah.
I've often wondered, this might be a question for you, David. You know, the sun is supposed to expand into a red giant and completely swallow the Earth. But the sun, you know, the outer reaches of the sun are not very dense. And it seems to me that and also the temperature isn't that high. So I'm wondering how long the Earth could actually survive inside the upper reaches of the sun. Is it for a geological length of time, or would it decay due to atmospheric drag and collapse into the center?
Well, that's something I don't actually know the answer to. It's something I've kind of wondered, though. So it's a good question. I think the thought is on this particular planet that it probably was something that was pulled in close to the white dwarf, basically due to something like atmospheric drag. And I think probably that would be essentially the fate of the Earth. Is I don't think the planet would necessarily vaporize in the outer shells as the sun expands, but probably would just eventually be pulled into the core of the sun.
And it's thought that as the sun ages, Earth will actually become uninhabitable long before the sun turns into a red giant. And that's just because the sun actually has been brightening, its luminosity has been increasing over its entire history. So that early on, it was actually, right at the, when Earth became habitable, after it cooled off, the sun was only about 70% the brightness that it is today. And it's been slowly increasing and is expected to increase continuing into the future to the point where it's thought that perhaps in another, maybe 3 or 4 billion years, so the last billion years before it turns into a red giant, the sun will actually get hot enough that it will start driving all the water off the surface of the earth and slowly make it uninhabitable. And so if humans are still around, or if some other intelligent species is around to help preserve the earth, I mean, what you might want to try to do is move asteroids and have them, move them and have them fling them past the earth, so that you get a kind of a rebound effect and slowly migrate the earth further away from the sun in order to keep the same sort of solar insulation.
I was going to say, when you said the earth is going to become uninhabitable, that sounds like quitter talk. I'm glad to hear you.
I mean, you probably will still have bacteria living deep underground, and so you could have whatever remains turn into or the intelligent species turn into Morlocks and burrow underground too. I mean, there's definitely a lot of science fiction ideas, directions you can go.
I'm gonna, if I can, Courtney, I'd like to address the elephant in the room and talk about COVID just briefly.
Sure.
Not that I'm an expert any more than anyone else is, but I think we're all kind of voraciously consuming the science news about COVID. And it's a novel virus, even though it resembles other coronaviruses. It attacks the human body in a completely different way. So there's been really just kind of balls to the wall research on exactly what this virus does inside the body. And I think if we're talking about scientific achievements for the year, it's remarkable how fast progress has been on the understanding of this virus, on the development of treatments for it, on the, hopefully, knock wood, development of vaccines. I think 2020 has been a rough year in a lot of ways, but we should give credit where it's due and say that the scientific community, there have been problems. Let's not gloss that over. But I think that on the whole, the scientific community has responded to the challenges in a very admirable way. And the rate at which science is progressing is, not only is it phenomenal, not only is it going to lead to cures potentially, or at least treatments for COVID, but it wouldn't shock me at all if, just as a side effect, we get a cure for the common cold and just a greater understanding of how viruses attack living cells. So I think that we're going to see, this year we're just trying to get to the vaccine, but I think we'll see dividends from 2020. 2020 will in a lot of ways be remembered as a breakthrough year when a lot of things became understandable or understood that previously hadn't.
I think on that note, if I may, one of the things that strikes me is I've heard several times, people refer to the effort on finding a cure for COVID as being a very Manhattan Project-like thing, except that unlike the Manhattan Project, this is not a top secret enclave of scientists. This is actually people working on much more open source kinds of documents and
all over the world.
Much more sharing things all over the world. And as you say, I think we can't help but have some tremendous achievements out of that.
I don't think we're actually putting the government effort behind it at all. The Manhattan Project had that.
Yeah. And that's why it was secret and stuff like that too, which made a big difference. But one thing that kind of goes along with this on vaccines, right now we're interested in COVID, of course, but within the last year or so, I saw that they've come up with a vaccine for another pandemic, and that's Ebola. And it's been accepted to be distributed and stuff, particularly there in Africa and stuff. So, we're obviously concerned about COVID right now, but in certain parts of the world, Ebola probably presents as much of a danger as COVID does.
At
and
least.
it's much more deadly even, so.
I think what all this research, that everyone has been following along has also shown are all the holes, all the places where our knowledge wasn't very good. It was pointed out very early on that the whole 6-foot social distancing was based on studies that occurred earlier in the 20th century, when they were looking at how far respiratory droplets would fall to the ground after someone coughed or sneezed, but these droplets were large enough to actually be affected by gravity and would fall downwards. Whereas now we know that aerosols that are much lighter and would float in the air for many tens of minutes, if not hours, are a much greater risk than those large droplets. And so until you are faced with the facts or with the situations where you're forced to reassess everything that oftentimes you don't know what your blind spots are in science. And it's really important for scientists to be able to see and understand what they are missing. So I think there's really interesting lessons to be learned just about how science is practiced, and trying to recognize what we know, but also perhaps what we know, information that might not be as secure as we thought they would be. And so I think it's it's always useful for scientists to be humbled by that sort of thing.
We had someone who asked a question, but on my screen, we didn't get quite to the end. It was about a 14-year-old girl who did something. It kind of stopped right at that point.
Yeah, so I can read the whole question. What are our thoughts about the 14-year-old who won the $25,000 prize for finding the potential molecule that would help provide a treatment? And
Okay.
I haven't actually read up too much about it, but it was a science fair project by a young woman, and she had, I think, done a sort of a computational study to examine several million potential molecules to see which ones could be used to that would. And again, I'm not an expert in this, and I also just barely skimmed an article about it. But she was able to identify a molecule that could latch onto the virus. So, and that's pretty much all I know.
Yeah. Yeah.
But no one else.
No.
Not by-
Sorry, we have the wrong crowd here.
One of the things that's interesting about the vaccine effort, unlike a lot of other viruses, there haven't been any coronavirus vaccines previously. So we're blazing new trails in more ways than one. That being the case, I mean, certainly the word on the street is that the vaccines that we can expect, at least the first wave vaccines, are probably only going to be about 50% effective at preventing the disease. Now, 50% is huge.
Right.
If you want to talk about driving the transmission of the disease down, that makes it a lot harder for the virus to transmit, and it could get to the point where it'll burn out on its own. But we're still going to be needing a lot of treatments.
Yeah.
And yeah, ultimately the treatments are all at the molecular level. We want to interfere. The virus is this very sophisticated nanotechnology machine that approaches cells and latches on and opens up an aperture and injects material. These are very mechanical operations that the virus has to perform. I mean, chemistry underlies them, but what happens is very physical and mechanical, and you can interfere with these processes. Everything has to go right for that process to work. So most of the treatments, other than simply anti-inflammatory kind of palliative treatments, anything that inhibits the ability of the virus to actually attack our cells, that's happening down at the molecular level.
And
There's also a question in the Q&A. Oh, actually, were you gonna comment on that, Dave?
Oh, I was just going to real briefly just say that, yeah, one of the things that's very nice about this and about all of this work being so open is it does allow, the one thing I can say about the 14-year-old's contribution is how just important citizen science can be in a lot of these different areas. I know it's certainly come up in planetary science, where people have done citizen science looking for planets around stars discovered or by systems examined by the Kepler mission and by the TESS mission. But yeah, it's I think, you know, we can never really discount what people can do when this data is available and people can look at it.
So what I was about to say is that there is a question from Paul in the Q&A window, which is separate from the chat. If people can catch COVID-19 more than once, is it even possible to vaccinate against it?
Well,
And there definitely are cases that have been reported, and they are rare, but it does seem like there are some small minority of people who have caught the virus a second time, and because the virus that they had was genetically sequenced, and they could resequence the second time that they got it, they could show that they were infected and got sick from different strains of the virus. And some people were more sick the second time, and I think, but other people were less sick as well. So there does seem to be a lot of really strange behaviors with this virus.
one of the things, I mean, no one really knows, and especially not me, but if you want to look at how immunity to COVID-19 works, it can be instructive to look at how immunity works for other coronaviruses, in particularly the ones that cause the common cold. Not all colds are caused by coronaviruses. Some of them are caused by rhinoviruses and other things. But if you get a cold from a coronavirus, you're immune to that particular cold for anywhere from 6 months to 3 years. But at the end of those 3 years, you can catch that exact same cold again. Why that is, I'm not sure. But I think it would be a mistake to assume that if you catch coronavirus or if you have the vaccine, that you're immune forever. What we need is for enough people to be immune for enough time that the virus is able to burn out and stop at least being this pandemic. It may flare up here and there, sort of like Ebola does. But, you know, we just want to slow it down.
Yeah. And that's kind of important right now. Yesterday, we had the record number of new cases here in the US. Now, part of that's testing, but part of it's depending on how you want to count, second or third wave here coming, that they've been predicting the next 6 to 12 weeks are going to be pretty important in the pandemic, how things are held. And
like a bunch of geniuses, we opened up all the schools.
Right. Well, you know, it gets really difficult, you know. More lives could also be lost if the kids are kept at home with their parents. Then at least the kids' lives might be lost. For old men like me, the virus will probably do it. Just one thing that I think's been kind of interesting. I don't think I had heard of CRISPR, the gene slicing technique, and working on that until about this time last year. And they won a Nobel Prize for that in chemistry this year. That seems like very fast to me. Usually,
CRISPR's been around for a few years, but yes, it was very fast.
Yeah.
I mean, I think it just has to do with how revolutionary it was as a tool for extracting and replacing segments of DNA and being able to edit the genome. And from what I understand, this is something that isn't completely new, because we've had the ability to go in and change DNA or part of a DNA molecule for a long time. But all those past techniques were very error prone, meaning, and this is something that you don't necessarily hear about because it's not, the people advocating these past techniques. You have to kind of squeeze them to find out what the error rates are. But you might have one successful change in a set of cells out of 100 or 200 tries, whereas CRISPR, the success rate is far, far, far higher. And so that is really the primary reason why it's so revolutionary compared to a lot of the past techniques.
Yeah, we did get one question here on why did the 1918 influenza go away without a vaccine? I'm not sure it totally went away.
No, I mean, from what I understand, we still live with the 1918, the descendants of the 1918 virus. And
I caught it. It was bad.
Yeah.
But apparently, I mean, one of the explanations that I read about why the 1918 pandemic was so crippling for younger people, so it was the inverse of what's happening with COVID today. So older people were not as affected, whereas it was killer for many young people, especially men who went off to fight in World War I, was that because it was a flu, it was an influenza virus, so it was actually related to all the other flu viruses. So older people had been exposed to, not that exact same virus, but they had been exposed to similar viruses over the years. And so they had built up more of an immunity to it than younger people who haven't had as many years and haven't gotten sick as much in their shorter lives.
And although I'm certainly not a specialist in the 1918 flu epidemic, it strikes me that because the flu tends to be more seasonal than coronavirus, that would certainly have been a factor in things. You could guard against it a little bit from the seasonal behavior. And I think there was hope that that would be true with corona, but it turns out, coronavirus just kept going.
Yeah.
I mean, was it a herd immunity sort of thing that caused it to decline? I don't know. I'm asking the question because there was no treatment for it.
Yeah, I think that's almost certainly what happens. That flu was very widespread. It reached every corner of the earth in a period of just a couple of years. I mean, literally every corner, no matter how remote. I think it must have been spread by birds in order to reach everywhere so quickly the way it did.
Right.
But yeah, I mean, if it gets everywhere and it's very widespread, then that's how things burn themselves out. It doesn't mean the virus went away. It just means it had too small a pool of uninfected people to keep spreading.
Right. I don't know what the mortality rate was, but people did survive it.
Oh, sure.
Yeah. Like you were saying, it was the young people from 20 to 30 who died in the Spanish flu, as opposed to COVID here, where it's the people over 60 who haven't. By the way, we do have a couple of comments in the chat portion of people saying that there's a very good documentary on the influenza on PBS, if people want to try and look it up.
Okay.
So, one other interesting thing that they've been coming up with recently, as a kid, it was supposed to be, there were, you know, Neanderthal cavemen, and then Homo sapien came along and kicked them out, and, you know, we're surviving. And there's been lots of recent work on a third form of human. I can't pronounce the name very well. The Denisovian
The Genosian,
Denisovans.
people who were around, and apparently all mixed in with ours, because as with all human species, I hope I'm coming through. It's my internet's unstable. It just said, I think that's why you were stuck, Will, when no one else was for me. But
you've cleared up. You were stuttering there a little bit with the signal, but I think you're coming through clearer now.
okay, the sign's gone off. Anyway, there's been at least 3 kinds of humans that have interrelated over the years, and they seem to have died off, I think, about the same time as the Neanderthals. But
right.
In fact, actually, I just read today an article about the Neanderthals and this other group. It turns out that they had done some genetic comparisons and found out that they are closer to each other than, say, polar bears and brown bears, I think it was.
oh,
Yes. Yeah, the Denisovans was considered a branch offshoot that developed into a different species from Neanderthal.
Yeah, the Denisovans
still got together and partied. Yeah.
I mean, originally the Denisovans were, I mean, I think it was like a toe bone that was discovered in a cave in Siberia, and that's where the name Denisova comes from,
Right.
from that location. And they have been extracting DNA from that, but there have been other discoveries since. It basically shows that there were multiple species of Homo, so not just Homo sapiens, but Homo neanderthalensis, and then now the Denisovans. And then people were still arguing about the hobbits down in Indonesia, which could consist of yet a 4th branch of humans, slightly different species. And I think, again, it's very interesting to think about that. Today we are the only intelligent species on the earth, and people can argue about how intelligent we really are. But if you go back 100,000 years, there were multiple hominid species that, and I don't think it's accepted anymore that Neanderthals were stupid cave people. I mean, they had culture. I mean, they might not have had the same levels of being able to communicate and be as expressive as modern day humans are or were. But they buried their dead. They had ornamentation.
I should point out, what you're talking about was the subject of a novel of mine that came out last October. This is actually the behind me is the cover of that novel, although the title doesn't seem to be in there, but it's called Antediluvian, and that's part of what it's about. That's not the whole thing, but thought I'd mention that.
we're getting real close to the end. So I'd like for people to think for a moment if on any parting comments you want to make before we get cut off. David, do you have any comments you'd like to make?
Well, I think 2020 has been a year where we've learned new ways of working, and I think we're learning new ways of collaborating. And I think, we've certainly in my business, we had been moving towards more remote observing, which kind of allows people to do a little more efficient use of computer to use telescopes from their home or their home institution or even their home. and with 1 or 2 people on site. And I think, we we have just pushed that a little bit further as kind of a fringe benefit of the, so to speak, of the COVID epidemic. I think we're going to just see more of that in the months to come as we kind of learn to work safely in this environment.
Steve, do you have any parting comments?
I do. I mean, and I kind of like to amplify what David said, which is, I think that this has, from a sociology standpoint, been very revealing. One thing, I mean, like in technology, doing software development, nobody's going to go back to the office again. I mean, even if we're all healthy, it's not a productive environment. And so I think that this is really showing that there's going to be a real change in what we consider to be work and what is the workplace. I think it's great. On final note, I want to go back to the discoveries with the human ancestors. I think we are seeing complete galloping progress being made in that, both from at a genetic level, the discoveries that are being made, and also, we are finding trace evidence of ancestors we never knew about.
Chung?
I think, jumping off of what's been happening in 2020, this is a field that we haven't touched upon at all, but I want to just touch upon psychology and the fact that, a lot of what the psychologists and sociologists have known about, and I think this year confirms, is that people don't necessarily and often don't make decisions based on facts or science or information that can be factually checked, and that a lot of what drives us are our passions, and by the allegiances and our tribal allegiances, and who we think of as part of our in-group. And I think this is a year where that picture is really nakedly obvious, and it's something that us in the science communications field, I work at a natural history museum, that's something that I think we will have to grapple with for forever, basically. But I think it's pretty clear this year that this intrinsic human nature, which has always been there, but it's just really obvious more so this year than any other.
Will?
Well, I just wanted to say that, one of the ways I make a living is as a patent agent. I write and prosecute patents, and I'm right up against the fact that patent filings are way down as a result of COVID. It's true for certain kinds of work that people are more productive at home, because you don't have time spent commuting and shaving and putting on clothes and all that annoying stuff. But when it comes to actually inventing new things, a large component of that is being in a laboratory or a workshop, actually leaning over things and tinkering with things and figuring out that this doesn't work, but if you did it this other way, that would work, and now you've made an invention. The kind of source of creativity has been undermined by the pandemic. And so we're going to see some fallout from that too, that next year's year in science may not be quite as impressive as the past several years, just because there's less going on.
It'll be interesting to see what the panel talks about next year here. I'd like to thank all of you for being on the panel. I think we've gone pretty well. I think it's worked well. I think your comment, David, about the pandemic has given us new ways to work. I think it's given us new ways to play and go to science fiction conventions and stuff. thank you all for participating. I'd like to thank all of our audience for putting up with us for the last hour or so. I think we're supposed to be finishing up here real soon. Any final comments, either from Mile High or our audience looking on? I don't see anything.
We're good.
Oh, I just got a call that there were 6 to 7 minutes remaining. I thought this was going to go about like a normal panel and last for about 50 minutes, but apparently we're going pretty close to an hour. So anyone else with any final comments? We've got a few more minutes than what I expected.
You want to? I actually have another story that I could talk about, but if you have something, Courtney, since you're the moderator.
Just real quickly, one of the big problems with electric cars, of course, has been the range, because you can drive them 200-300 miles depending on the car, but then it's a long time to recharge. I read that they were working on a fast recharge where, interestingly, you heat up the battery and then charge it to within about 80% of its potential in only about 10 minutes. I think that would make an enormous difference in electric cars. People, could drive down to Albuquerque or up to Albuquerque, depending on where they live there, David. You could drive a couple of 100 miles, grab a cup of coffee, go to the bathroom while you're charging the car for 10 minutes, and then you're off again. It's not quite as fast as pumping gasoline, but 10 minutes is, I think, a doable amount there. So,
yeah, I know with I drive a smart car, one of the little compact cars, and even the electrics of those take like an 8-hour charge. So, and the range is only about 200 miles. And since I regularly drive between Las Cruces and Tucson, it's like that's longer than the charge distance. So unless I wanted to do a 2-day commute. So yeah, it would be really nice to have an electric car that you could actually charge in about 10 minutes.
And I don't know much about this. I just have a 9-minute battery charging could accelerate electric vehicles prospects, but at least the working on it and thinking of it, it might make them much more usable out here in the West.
I've been following intently the battery improvements and new battery science taking place. It's very, very interesting stuff.
Yeah.
Yeah, I mean, the battery work is almost akin to Moore's law in the sense that it's, the prices for the amount of energy that you're storing has been dropping pretty, considerably, and that trend doesn't look like it's going to stop anytime soon. And so, the batteries that are available today are much better than what was available 5 years ago, and will be available 5 years from now will be far better than what we currently have. And so, people continue to invest in and continue to do research in battery research. So I think the future is bright for powering cars and whatever else from electricity.
I agree.
You were going to say something else, John, earlier.
Oh, I had one other astronomical discovery that I just wanted to highlight, and this was announced back in January. The Radcliffe Wave, which was using very accurate information about the positions of stars close to our sun to measure the distances to molecular clouds and star formation regions. And whereas before we thought there was a ring of clouds and around our solar system, now it seems like it's just a kind of a long wave-like feature that's about 9,000 light years long. And in the past, people when this was a ring, people were wondering whether it was a supernova or some kind of burst that created this multi-thousand year light year structure. And now they're wondering whether it's a satellite galaxy merger or some other collision with a giant cloud of gas that caused this. So the Radcliffe Wave is just an interesting structure in our part of the galaxy that because of recent advancements in how accurately we can measure stellar positions, we're able to map these structures. You can see the forest, even though our view is blocked mostly by the trees. So a really interesting advance and to understanding what our local galactic region is like.
I was looking just recently, I saw a thing about someone saying that we're actually passing through a supernova. Is this part of what they might be talking about?
They might be what you might have read about is the local bubble. So there is a large multi tens of light years size bubble of hot gas that the sun just happens to be moving through in its orbit around the galaxy. So that this hot bubble might have been caused by a supernova long ago. Yeah, there are pockets of hot gas throughout our galaxy, and this is just the local one.
Okay, we did get the notice that less than a minute, start wrapping up. Thank you, everyone. I think we're done.
Thank you.
Bye, everyone.
Thanks, bye.
Thanks, Courtney.
I thought this worked well. It's interesting to have panels virtually here, but it seemed to have worked earlier. I think this one worked pretty well too, didn't you?
Yeah.
Yeah. So, well, hopefully I will see and smell all of you guys next year at MileHiCon.
Very good.
Bye.
Indeed. Thanks.
Right.
We'll
Bye-bye.
Later.
bye.